Hi guys, and welcome to Let's Think About It. Today I'm going to be showing you my proof for a round Earth. We're not going to be using the Hipparchus method or going over any mathematically heavy concepts. We could, but I wanted to focus on a proof that is sweet and simple. One that's self-evident, but definitive. There's no if, and, or buts when it comes to this proof. So this picture of two airplanes, that's my proof right there. Okay, so now we're going to get into it. Forget about any notions you have about the Earth. Whether you think it's a cube, well, no one thinks it's that, or you think it's a flat Earth or a round Earth. Whichever one it is, forget about those. We're going to just consider them equally right now. We have two different models, the flat Earth and the round Earth. The flat Earth is a disk, like so, and it doesn't move, and there is a spotlight sun that moves around it and orbits it. Well, I don't know if they call it orbiting it, but that's basically what it does. And this circle can open and close to change the seasons, and the spotlight's movement, that's the day and night cycle, according to flat earthers. Now, there are some things that are contested within the flat earth community about the flat earth model, like the moon, for instance, but the spotlight sun is not one of those things, so that should be relatively easy to just go out in this particular proof. It's very important to the proof, and they're very adamant about spotlight sun existing. And the existence of a spotlight sun is all we're relying on for this proof, not its altitude in the sky, which is something else that's contested, but just the fact that the sun is a spotlight. On the round Earth, you have one ball that's further away from a much bigger, brighter ball. Our ball orbits the much bigger, brighter ball at an angle of 24 degrees, and that creates the seasons, and then our ball rotates, and that creates a day or night cycle. Okay, so what we're going to do is we're going to take these two models and we're going to see what their predictions are, and we're going to see if their predictions match reality. That's what any good scientist does. We could go into some complicated things. For instance, I don't see how cold fronts could form on a flat Earth, or why hurricanes would move upwards from Cuba towards Florida and then New York on a flat Earth, but those can get more complicated. So we want to keep this one sweet and simple. So what we're going to be focusing on is the transition from night and day, or day and night, sunset in this particular case. And we're going to be focusing on one very particular thing, objects that are higher in the sky versus objects that are lower in the sky. Which one enters nighttime first? Okay, let's look at the two models and see what they predict. The flat Earth has this conical sun because of its spotlight feature. Okay, so that means any airplane that is higher in the sky should be entering nighttime before any plane that's lower in the sky, just because of the way the spotlight sun works. And now we're going to look at the round Earth. The round Earth has a bunch of parallel rays hitting the Earth, and the Earth blocks the sun on the other side of its own self, and that creates a shadow. That shadow is what nighttime is according to the round Earth model. Now, any plane that is lower than this tangent line, you see this tangent line right there, where the parallel rays of the sun hit the Earth. Any plane lower than that will be in nighttime first. So on the round Earth model, the plane lower in the sky is in nighttime first, and the plane higher in the sky stays in daylight. On the flat Earth model, it's the exact opposite. This is perfect. They do completely different opposite things. They predict the exact opposite. It's a binary situation. It's definitive. Whichever one they say, that's which one it is. When you have a spotlight, you have this conical shape, which means you have to have the object higher in the sky be in nighttime first. Okay, so now what we're going to be using is there are planes where I live in New York that are around 15,000 feet as they're approaching Kennedy. Kennedy has some of his arrival procedures go right over my house. And Dulles Airport has some of its airplanes that are going to Europe also go right over my house at around 35,000 to 40,000 feet. Well, there's a chance they can crisscross each other and be one on top of the other. Well, that's perfect. We can hopefully definitively see whether one plane is in nighttime before the other one is. One of the things I had to do is I had to make sure it was a clear sky for hundreds of miles around. This way, no cloud could block any plane. Because it's kind of an easy thing to think of, right? If there is a cloud here, you can have that cloud block the plane that's lower in the sky or a plane higher in the sky. So we had to make sure for hundreds of miles there was no clouds. Okay, so on July 9th, 2018, I was coming home and I noticed it was completely clear for hundreds of miles. It was a perfect day to do this, and Kennedy was using one rays 4 left and 4 right, which means they're going to be using the planes going right over my house. I got my camera ready, and I got this photograph. And you can see right away, the 737 that's higher in the sky than the A330 is still in daylight. And you can also tell it's higher in the sky because there's a contrail, which has to happen above 18,000 feet. But that's it. That's pretty definitive when you think about it. The plane higher in the sky, that's still in daylight. That can't happen if the sun is a spotlight. It can only happen with the round Earth model. If flat earthers wanted to change it in order to accommodate the fact that the plane higher in the sky stays in daylight longer, they'd end up back at the round Earth model. So that's it. We see this in other places. We can see it in rocket launches. When SpaceX launches a rocket early in the morning, sometimes you'll see that the rocket enters daylight. And it's a beautiful thing to see. But I didn't want to use rockets because most people don't have access to rockets to see them. And rockets have a trajectory that's not straight up. They actually curve a little bit, so not exactly the perfect proof in my opinion. Clouds also do this though. You'll notice on a sunset or on a sunrise, the cirrus clouds at around 40,000 feet, those will still be in daylight. While the cumulus clouds, those little puffy clouds, they, in a sunrise, are the last to become illuminated, and in the sunset, they're the first to become dim. But I think the plane proof was the best. And to me, it's very definitive proof that I can use almost every day that the Earth is round. Because the only way you can get the plane higher in the sky to stay in daylight is on the round Earth. I also once saw the curvature of the Earth and the shadow of the Earth, that inclined plane while I was on a plane back from Europe. And there's a picture of that. You can see the little tiny plane increasing in angle. Again, that doesn't happen with a spotlight sun. It just can't. The sun would have to somehow go below the horizon, and that only happens on the round Earth model. That's it. For me, that was it. It was a beautifully elegant way to show the Earth is round, and I think it's very easy to understand. Okay, that's it for the first episode of Let's Think About It. This channel I want to be more of a discussion, so obviously hit up in the comments and let me know if you agree with this or refute it or whatever. I'm sure I'm going to get a lot of flat earth comments, but I want them to use their logic and not just that someone is trying to control us through NASA who makes no money. So yeah, that's it. Thank you.